time-critical type of code. You will not use C#, you will not use Java, you will use C, C++, okay? So that's why all operating systems internally are written in which language? Some is, of course, assembly language, but most of it is C and then some C++, okay? All video games are majority created in C, C++. Even if we use Java or C#, the core engine is always written in C or C++, okay? So once it comes to speed, nobody beats C, C++, okay? Why? Because we directly compile to machine code, okay? Now let's come to Java and C#. Both of them do not compile to machine code. Okay, so the question is why? What benefit we may have by not compiling to machine code? So let me quickly show you. Okay, see, when Java language was created, it had 3 goals in mind, okay? Make object-oriented programming easier than C++. Number 2, make it operating system independent so that we can run Java program on any operating system. Okay, and number 3, no memory leaks, so that the programmer does not have to worry about releasing memory from the heap area. So those were the goals of Java, okay? So how did they accomplish this? Let me go one at a time. First, let me show you this part. How do we make a language operating system independent? Okay, one of the key things is, so key concept is not to compile to machine code. Because the minute we compile to machine code, we are stuck to that particular operating system, okay? So as we discussed, if we take a Java program, if we write a Java program, we pass it through the compiler. Do we compile it to machine code or some other code? Byte code, right? And byte code, as I mentioned again, it's not machine code. Okay, so how do we run it? Then if this is the CPU, okay, in the memory of the computer, what do we load? JVM. And what's the one of the important parts of JVM? Bytecode interpreter. Right? So this will read the bytecode and tell the CPU what to do. Same way, read another line, tell the CPU what to do, right? Okay, so now how does it make it operating system independent? Okay, pretend this is, let's say, Windows operating system. Okay, now let's go to Mac OS. Okay, so again, so if this is the Mac OS as an example, okay, let's pretend somebody has developed the JVM for Mac. Okay, so this is the JVM for Mac, right? So of course we can load it over here, right? And what's the first important part of the JVM? Bytecode interpreter. So how will it run the same Java program? We don't even have to compile it again. See, we already compiled it one time. So this JVM will simply read this bytecode, tell the CPU what to do, read another line, tell the CPU what to do, without having to recompile it, right? So all we need is JVMs for different operating systems. And how many popular operating systems there are?
3.
Maybe 4 or 5 at most, right? Unix, some variations of Linux, Mac OS, Windows. So somebody can sit down and create one JVM for each operating system. So this way we just compile it once, we run it again. So once again, let me emphasize, if you wanted to create a new language tomorrow, okay, to compete with Java, Python, or whatever, and you wanted to make it operating system independent, what's the #1 rule you will need? As you compile it, you will compile it not to the machine code, okay? You will create your own intermediate code, which you can interpret, right? What's the price we pay for this flexibility? Speed, right? So anytime we interpret, it becomes slow, right? Now, second and third parts, as I mentioned, the second part over here was the garbage collector, right? So that as we keep using the heap, programmer does not have to worry about it. So that's why Java programs are very stable. You can run them for years. They won't overflow in our memory, right? And third part is the safety environment, so that if our program tries to access a protected area, which is only the operating system can use, it will immediately block us, right? Okay, so now Java was released in 1995. The .NET framework, of which C# is one of the languages, okay, was released in 2000. So for the most part, what they did in the .NET framework, they looked at Java, copied all the good ideas, and then introduced some new ideas. Okay? Because it came later, it can learn from Java. So once we write a C# program, again, our goal will be to also have operating system independence. So you can run C# on Mac, you can run it on Linux, you can run it on Windows. So anyway, how? As I mentioned, just like we have JVM to run a Java program, what is the equivalent in the .NET world? So if this is the CPU, it's called CLR. Okay, so we will load CLR in the memory of the computer. CLR stands for Common Language Runtime. Just like JVM, it has 3 parts to it. What's the first part? Well, what's the second part? Second, third are the same. Garbage collector, safety. In my opinion, the runtime safety is a little better than Java in C# and .NET because it came later, so it can do a little better version control as compared to Java, as an example. Okay. Okay. Now the first part, remember our goal is operating system independence, so we cannot compile to machine code, because if we did that, then we'll be stuck to one operating system, right? Every time we wanted to run the program on a different operating system, we'll have to recompile it, okay? So the first part is not the same as Java, okay? The first part over here is just-in-time compiler, okay? What is a just-in-time compiler? Okay, so if we wrote a C# program, again, we'll compile it, but we will not compile to machine code. This is called IL code, short for intermediate language code, and not machine code. So that, just like JVM, we can create a CLR for different operating systems, and we can run the C# program on any operating system without having to recompile it, right? However, if we made it over here an IL interpreter, then C# will be same slow speed as Java, okay? So to make it faster, what this just-in-time compiler does it reads the IL code, and then it converts it to machine code. So then it will read some more IL code, convert it to machine code. So as it's running, it keeps converting it to the machine code. CPU only runs the machine code. So it directly goes to the machine code and runs it. The rest of the garbage collection safety environment are provided to this machine code as it runs it. Okay. So as you can see, the very first time we try to run a C# program, it will be slow. Why? Because not only it's reading the IL code, it's converting it to machine code. But one time we have run the program, it will cache this, meaning it will store it in the CLR. So it caches the machine code. So now if you try to run it again, it will directly execute the machine code, so it will run almost the speed of C, C++. So almost speed of C, C++. Okay, why do I say almost? How come it's not 100% same speed as C, C++?
It doesn't have to access the cache only.
If this is machine, I mean, I'm comparing the speed second time, not the first time.
Just check the code.
Okay, C and C, C++, is there a garbage collector kicking in, checking the heap?
No.
No. Remember, anytime the garbage collector kicks in, CPU has to devote time to the garbage collector. Okay, so over here there is a garbage collector. So roughly speaking, C# maybe 10 to 15% slower than C, C++. Okay. Again, the safety, that garbage collection requires the CPU to switch to another thread, and that's what slows us down, right? Okay, so to summarize the main concept, the main concept is both C#, Java are very similar to each other. And that's why I was saying, if you learn one of these languages, literally it takes you a day to learn the other language, okay? They're not that different. Same thing, the other good news is, if you know these two, to learn C++ is another day's job, okay? So anyway, what are the similarities between the two? To run a Java program, we load JVM into the memory of the computer, which interprets the bytecode and tells the CPU what to do. Okay? Just as a minor point, Java also has a just-in-time compiler. Okay? Optionally, you can use the just-in-time compiler so that it will do the same thing like C# is doing, meaning it will convert to machine code and cache it. Okay? However, because Java emphasizes interoperability more than C# does, it discourages the JIT. So it's there, but nobody uses it, okay, in the practical world. Whereas in C#, JIT is mandatory. You cannot interpret the IL code. You have to convert it to the machine code and run it, okay, as part of the runtime environment. Okay, so now to complete this comparative study, how do we achieve no memory leaks in Java? Garbage collector, which once again monitors the heap. If the reference count, meaning nobody's pointing to that object, becomes 0, then garbage collector will remove that from the memory, right? Makes sense? Does C# also have garbage collector? Yeah. And the answer is yes, works the same way, so they're equivalent. You as a programmer do not have to worry about memory leaks in C#, okay? Safety runtime environment, we'll go into this deeper as we go along. Both have pretty safe runtime environments, slight different concepts. Towards the end of the course, I'll point out what those differences are. So for right now, they are both pretty safe runtime environments, okay? Running wise, C# is tiny bit faster than Java for the most part. There are some benchmarks where Java does a little bit better, but on average, C# is a little bit faster because it compiles to the machine code, okay? Now, let's come to this part, because our goal is to be really good in object-oriented programming so that we can create large applications as nicely as we can, right? So when Java was created, they wanted to make it easier than C++. So basically they kept same syntax pretty much. So same syntax as C++ with a few minor differences. Okay, for example, those of you who have programmed in C++ or C, there are no header files in Java or C#. Okay, you simply write a class just like we did the student class. You declare the fields, the public get sets, the methods in it, or the public functions in it. Everything is in one file. Okay? Unlike C++, where the variables and the prototypes go in the header file, the actual code goes into a separate file, so there are no header files, right? Okay, what are the other differences when Java was created? So Java initially had no templates. Okay, again, those of you who know C++, there's a concept called templates where we can write code so that it can operate on different data types in a much easier way. For example, if you wanted to create a stack class, you can create a stack of integers, doubles, strings, and so on, right? So just by creating one template class, you can easily switch the data type. So when Java was created, they thought, oh, templates are a little bit complicated, so let's eliminate those, okay? Then later they added. So later added as generics, which is same as templates, okay? The other thing Java did is no operator overloading. Okay, so again, this is Java I'm talking about. So for example, if you created two strings, s1 equal to hello, let's say s2 equal to also hello, okay? And if you wanted to compare, are both strings same in Java? If you try to write this code, if s1 equal to s2, will that work in Java?
No.
It will always return false, even though they contain the same thing, right? So how do we do it in Java? Because there is no overloading of the equal to operator.
S1 dot equals.
So you have to do in Java s1 dot equals s2, right? However, now coming to C#, okay, so now let's compare it to C#. C# has what are called generics, slightly more powerful than Java, so which is again equivalent of templates in C++. C# does have operator overloading. So meaning, in the same example that I gave you in C#, you will write s1 equal to s2, and it will return true if both of them contain the same data, okay? I myself run into a big problem off and on, because if I'm programming quite a bit in C#, then if I have to switch to a Java project, off and on I forget. So because see, Java will not give you an error if you try to write this. It will simply give you wrong result, okay? So many times I've spent an extra half an hour then recognizing, oh, it doesn't work in Java, you have to do equals. Okay, anyway, So there is operator overloading, there is generics. Okay, then all the rest of the constructs, how do we create a class? How does inheritance work? How does polymorphism work? These are same in Java as well as C#. Okay. Now there are a few new things in C# which Java doesn't have. So extra features. And this is where towards the end of the course we'll be spending a lot of time. The extra features, one is called delegates. Okay. Lambda expressions. Okay, there's link, language integrated query. There is task parallel library. Okay, so these are some of the new things which, in my opinion, make the language quite a bit better than Java. Okay, so we will learn these towards the end of the course as we go along. Okay, so one more small difference between Java and C#. Okay, so now let's take a look at how do we creating applications in .NET. Okay, so the framework, so this is what's called the framework. Okay, see, when .NET was created, it had one extra goal as compared to Java. So these were the goals of Java, right? So .NET also wanted to keep these three goals, but it wanted to add the fourth goal over here, and fourth goal was any programming language. When Java was created, at least in the beginning, the attitude was Java is the best language in the world, you do not need any other language. Okay? However, when .NET was created, their goal was different programmers prefer different languages. Even you guys, as you are done with this course, some of you may like C# at the end. Some of you may say, no, I prefer Java, or I prefer Python, so that's perfectly okay, right? So, so the goal in creating .NET was not only we give operating system independence, but also we give language independence. So part of the application can be programmed in C#, part of it in Java, part of it in C++. At the end, we should be able to combine it together and make it work, right? So how did they achieve this? So let me show you the overall application architecture. Okay. So as we are creating applications under the .NET framework, these days you'll be creating 5 types of applications. So let me draw what they are. You'll be creating desktop applications. Okay, sometimes people call it Windows application. They run on your computer, right? You'll be creating web applications. Okay, like the websites that you guys go to and use every day. We also create what are called web services. Okay, web services are pure code. Some of you are in my 546 class where we have a course called Services Oriented Architecture, and you learn about web services. Okay. Then we also create libraries. So these are collections of useful code so that somebody else can use our code. And lastly, mobile applications. So these are the popular 5 types of applications we create these days, right? Computer Science 440 focuses on desktop applications. Computer Science 555 focuses on web applications. Computer Science 546 focuses on web services. this is also Computer Science 4440, so I will also be showing how to create libraries. In mobile applications, some of you are in that course, 441, smartphone application development. So anyway, so this way we are able to cover the entire spectrum. So anyway, all of these can be created under .NET. So what you do is, it doesn't matter which one of these, you pick a language. So right now, more than 100 languages are available under .NET. One of those is C#. So there's C#, C++, Python, Ruby, and anything imaginable that you've heard of is available under .NET. So you can pick any language. They're all equal citizens, okay? So as you create an application, doesn't matter which one of these you are creating, of course you will create some classes. Okay? So if you picked C#, you wanted to create a desktop application, you'll end up creating 10, 20 different classes, right? Now, when we program these days, not everything we create of ourselves. A lot of the power in programming comes from a library. So we will use the .NET Framework library. Okay, and we'll pick some classes. So these are pre-created classes. So pre-created useful classes. Okay, to give you an example, okay, suppose you were sending data from one computer to another. Okay, you wanted to send some data from here to here, right? Okay, and you wanted to encrypt it before sending it to the other side, okay? You wanted to digitally sign it, okay? So rather than you sitting down writing the code for all the encryption and digital signatures and so on, the framework library already has all the important algorithms, all the important encryption algorithms are already available, already pre-programmed. So all you have to do is pick the encryption class, call one method in it to encrypt it, then send the data. If our data comes encrypted, you'll call the method to decrypt it. So our code simply becomes 4 or 5 lines of code. All the encryption, decryption, all that hard work is done by the library class, okay? So this is a huge library, greater than hundreds of thousands of classes. It keeps getting bigger and bigger as time goes by. Any new technology that comes in, pretty much you can guarantee there's some class over here that will do the job for us, right? So once again, you as a programmer will write some classes. You'll pick a lot of the core useful classes from the library and combine them together, right? Okay, now this is already compiled into the IL code. So now you will run it through a compiler. Okay, so what kind of output will the compiler produce? Machine code or something else? IL code, right? Just like Java produces bytecode. So we'll produce the IL code output, okay? Okay, so now how do we run this IL code? Okay, so here's the CPU. Here's the memory. Okay, so what will happen? IL code will get loaded. Whatever library classes we were using will also get loaded over here, right? Now the CPU will take over, convert it to the machine code as it's running using just-in-time compilation, and the code will end up using the stack area, the heap area, and we'll run our application, right? Okay, so that's the fundamental idea. Oops, I'm already late. Okay, so anyway, we'll continue from this point on, but this is the major idea under .NET, how we create applications.